Okay, another pattern we saw in Chapter 7 was the multiplication of conjugates, which gave us a difference of two squares. So in this chapter, we're going to be undoing the difference of two perfect squares. The key here is recognizing a pattern. Now this pattern recognition is going to lead us right into our next section that we're going to learn. So recognizing a pattern is going to become pretty important. We did the first pattern recognition was the perfect square trinomial. Fortunately, perfect square trinomials can be factored in other ways, but as we go on in this pattern recognition, we get to ones that we just have to recognize patterns. So recognize the pattern that we have a binomial, right, two terms, and then these two can be exchanged, that we have a difference, and then that the square, that those difference are squares, right? Difference of two perfect squares. So once we recognize that, we'll want to find the roots, and then we're going to write the conjugates with the roots. So the root is a and the root is b. So a plus b, a minus b. Those are the conjugates, remember. So let's practice with our x squared minus 9, which you see up here as multiplying out. So we see binomial, we see a difference, we see squares, so we'll get the roots, x and 3, and so now we'll write as conjugates. And so our conjugates, remember, one has a plus and one has a minus, order doesn't matter, root and root, root and root, and there we go. That's our that is our factorization. All right, let's try it again. On our next one here, we have the binomial, difference, perfect square, so we need roots here and here, and now we're going to write them as conjugates, one with a plus, one with a minus. Order again doesn't matter, the plus could come first and then the minus, or vice versa, as I've written it. So there we go. There are our product of conjugates. Okay, next one again, we see a binomial, we see a difference, we see a square, so we need the roots here and here, and then we form the conjugates. Two binomials are conjugates, right? One with a plus, one with a minus, and we write in the roots. 2x here and 9 here, 2x here and 9 there. So 2x plus 9, 2x minus 9, order totally doesn't matter. And then finally this one down here, ooh, tricky, 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 we have a fraction, but remember the root of a fraction is the root of the numerator, the root of the denominator. So the root of this one is z, and the root of this one is 1 over 4. Square root of 1 is 1, square root of 16 is 4. And again, we'll write the roots, so as the conjugates. So one with a plus, one with a minus. Remember, order doesn't matter. That's our first root, that's our second root, that's our first root, that's our second root. And so we see z plus 1/4, z minus 1/4. Okay, now let's put in our pattern of GCFs. So we don't see roots here, right? So the first thing that I see is that I have a 3 in common with these. So I'm going to go ahead and write it as a GCF. 3 comes out of there and leaves me with 9z squared. Minus 3 comes out of there and just leaves me with a y squared. And so now I see, oh, binomial, difference, square and square. So I write the square root here and the square root here, and now I can write them as a product of conjugates. Don't forget my GCF, 3z plus y and 3z minus y. And so we have our factorization there. All right, in our last one, again, I don't see perfect squares, so let's see if I can take a GCF. If I take a 3 out, I'm left with a 4x squared minus, if I take a 3 out, I'm left with a 6y. Oh, and squared, and oh, I didn't get all of them. There was a 6 in common there. So I'll want to go ahead and take that out. That was an oopsie. And so I take a 6 out, and I say, okay, well that would leave me with a 2, and that would leave me with a 3, still not perfect squares. So what if I just took a 2 out? 2 out would leave me with a 6 and a 9. No way, shape, or form can I possibly get this one to factor, and that is a case where I didn't have factoring afterward, and remember that's always possible. With trying to factor a binomial by factoring a difference of two perfect squares, sometimes you won't be taking out that GCF to actually get the difference of two perfect squares, and that's why I checked all the roots.